In this set of examples, we're going to be taking a look at solving multi-step equations. Now, all the equations that we're going to be looking at in this case share some characteristics with this very first one that you see. All of them in this set of examples have a number on one side of the equation, and on the other side, you have the x and some numbers and some parentheses. And the very first thing we want to do, if we're going to be solving one of these, is we want to get rid of the parentheses. So we want to simplify everything we can before we actually start that solving process. So let's go ahead and take a look at this first one here. I got that 5 out front of my parentheses. So the very first thing I'm going to do is I'm going to distribute it into the parentheses. Now you notice the left side doesn't change at all because I'm not doing anything to the 85. It's only on the right side that we're changing anything. And there I am multiplying everything through by 5. So 5 times x is 5x. The minus stays a minus. And then 5 times 6 is 30. Now that we've gotten to this point, our equation looks a lot like ones that we've seen before. There's no more simplification that I can do over here on the right-hand side. And so instead, I'm just going to go ahead and start moving stuff to the other side. Now, specifically, which way do I want to go? Well, remember that I'm trying to solve it for x, which means I'm going to move the stuff out of that side that is not x. And the first thing I want to get rid of is any addition or subtraction, which means the very first thing I want to do is get rid of the minus 30 by adding 30 to both sides. So I add 30 to both sides, then that's going to give me a negative 55 equals 5x. Now to get the x by itself, I need to get rid of the 5 that is being multiplied by x. And in order to undo the multiplication, I then must divide. So we're going to go ahead and divide both sides now by that 5. Negative 55 divided by 5, well, it's a negative divided by a positive, which is a negative. And 55 divided by 5 is 11. And then 5x divided by 5, the 5's cancel each other out, and all we're left with is x. Which, now that we have x by itself, means that I have my solution. I know that x equals negative 11. Our next example looks very similar. Once again, we have parentheses on one side of the equation that we need to get rid of. Now, in this case, it's on the left side that we have the parentheses. On the last problem, the parentheses were on the right side. What does that change? Nothing. It doesn't matter which side it appears on. The very first thing we want to do is simplify it by getting rid of those parentheses. So in this case, I'm going to be multiplying the 2 into the parentheses. Now 2 times 5 is 10, therefore 2 times 5x is 10x. And then the minus stays a minus, and 2 times 25 is 50. And then that still equals 40, because remember the 40 is on the other side. The 40 is not in the parentheses where it's going to get multiplied. It's sitting over there all by its lonesome self, and so it just stays exactly as it was. All right, now that we've gotten to this point, we look to see, can it simplify it all like over here on this side? Are there any like terms that I can combine? And there isn't. One's an x and the other one's just a number. So there's nothing to combine there, which means we're now going to go ahead and start moving stuff from one side of the equation to the other. Again, I'm going to get rid of any addition subtraction first, which means getting rid of the minus 50. So I'm going to add 50 to both sides because I'm undoing the subtraction. So then on the left-hand side, I'm just going to be left with 10x, and on the right-hand side, I'm going to be left with 90. Then I have 10 times x, so I'm going to divide both sides by 10 in order to just leave the x behind. I'm always just trying to make it so that an x is all that's left behind on that side. Wherever the x was, I make it just an x. And then 90 divided by 10 is 9. And then since I have x equals, I have my final answer, that x must equal 9 for this problem. In our next problem, again, fairly similar, where we have the parentheses, and we need to start by getting rid of the parentheses. Just be very careful with this type. Oftentimes, I'll see people make a mistake with this, because what they'll end up writing is they'll get rid of the parentheses and they'll say it's 2 minus x minus 9. equals negative 3, which is not entirely right because we are still multiplying something into the parentheses here. You notice that minus is out front of the parentheses. That's like multiplying the parentheses by negative 1. And so if I multiply everything inside the parentheses by negative 1, well, that does give me a negative x, and so I write minus x. But negative 1 times negative 9 would be a positive 9, so I'm going to write that then as plus 9. So pay very close attention to this particular sign. People who have trouble with this particular problem, almost every single time, that's where the trouble occurs. All right, now that we've gotten this far, before I start moving stuff side to side in my equation, I notice that there is something I can do to simplify the left-hand side of my equation. I see some like terms that I can combine. So I'm going to do that. Notice I have a positive 2 and a positive 9. Well, 2 plus 9 is 11. So then I'm going to rewrite this then as negative x plus 11 equals negative 3. As a side note here, if you were thinking you would instead write it as 11 minus x, that's perfectly fine. That would also work. However, your next step will be the same as what I'm about to do. And I find that if I write it like this, it's a little bit easier to tell what to do next. Because I want to now leave the x behind, which means getting rid of the addition first. So I have to get rid of the 11. And notice that since the 11 is positive, I'm going to have to get rid of it by subtracting 11 from both sides. And so then, on the left-hand side, notice I still have that negative out in front of the x. And so I have negative x equals negative 14. Well, we're not done yet because I don't yet know what x equals. I know what negative x equals, but I don't know what x equals. Well, logically, you might figure out, well, if negative x equals negative 14, then x must equal 14. And yes, that actually is correct. Our final answer will be 14. Technically speaking, like from the algebra side, what are we doing to get that? Well, just like in the original problem up here, I saw that that minus was like multiplying it by negative 1. The same thing is going to be true down here, where when I write minus x, really I'm writing negative 1x. And for that reason, I'm going to divide both sides by negative 1 in order to get rid of the negative that's in front of x. So that's why our negative x just becomes x. So anytime you see negative x written like that, know that you can get rid of the negative by dividing by negative 1. Now our next problem here looks a little bit different because now we have two sets of parentheses, but the basic idea is still going to be the same. And that is we're going to simplify whatever we can before we start solving. And that means getting rid of the parentheses. On the left-hand side then, it's just going to stay at 13 because there's nothing on the left side for it to combine with on the left side. Right now we're only doing combining, so I don't care what's happening between the two sides. I only care about what's happening on that side. So then on the right side, I have this x minus 5 here. Now you notice there's no number written in front of the parentheses here. Well, technically the number that is out front is just a 1, but anything times 1 is just itself. So that x minus 5 is going to be x minus 5. It doesn't change at all because of the parentheses there, because there was nothing written out front of it to change it. Now for the other parentheses, what's out front of this parentheses? Well, again, it's going to be like a 1 because there was nothing else written there. Well, and again, if you multiply 1 times anything, it just equals itself. So like 1 times x is a positive x, and 1 times 4 is a positive 4. And so notice that when we are just adding the parentheses like this, I basically just was able to drop out the parentheses. But do make sure that you think about why we were able to do it. Otherwise, that could trip you up later because there are some things that can happen, like if we subtract instead, as we will see. They would throw a kink in that if you just said, well, drop them out. Okay. All right. Now then, having gotten rid of the parentheses, I now see that I have some like terms that I can combine on the right-hand side. So I'm going to go ahead and do that. Because over here, you'll notice I have an x and I have another x. Both are positive. So I'm going to be doing x plus x. Well, anytime you add two things, two like terms, remember they have to be like terms because that term stays the same. So since they both were x's, my answer will be an x when I add them up together. It's just I added an x to another x. So I have a grand total of two x's. All right, now I look at the numbers. I have a -5 and I have a +4. Okay, let's combine those. What is -5 plus 4? That'd be a -1. And so now I've combined the like terms, and now that I've done that, our solving process is the same as it always is, which is get rid of the addition subtraction on the side where the x is. And so I'm going to get rid of that -1 by adding 1 to both sides. When we do that, we end up with 14 equals 2x. And then again, I have 2 times x. And so if I want to get rid of the 2, I'm going to divide it, because right now it's 2 times x, and therefore we're undoing multiplication. And so we divide. So we have 7 equals x. And since I do, in fact, have the x by itself, that means I'm done. I know what x equals. X equals 7. Now, another problem, somewhat similar to that last one, right? Again, we have two sets of parentheses. Again, there's no number written out front of the parentheses on either of these. And so all I'm going to be multiplying in is a 1. And since this is a plus, both of them are going to stay the same signs as they were. So the left-hand side simplifies to just be 3x minus 9 plus 5x plus 3. It still equals 58, of course, because I'm not doing anything to the right-hand side right now, because 58 is just 58. There's nothing to combine it with yet. And on the left-hand side, now I can look for those like terms. And you notice I have a 3x and I have a plus 5x here. Those are like terms because they both have x's in them. And so if I have 3 x's and I add 5 x's to it, I'm going to end up with a total of 8 x's. All right, now I look at my numbers without x's. And I see that I have a -9 and I have a +3. So I'm going to be doing -9 plus 3. And -9 plus 3 is a -6. And so I'm going to write it as -6. And still equals the same 58. All right, now we're at that point where it should be familiar and comfortable. So let's go ahead and race through the end of it. I'm going to add 6 to both sides. And then I'm going to need to divide both sides by 8. And so we end up with x equals 8, because 64 divided by 8 is 8. And since we know what x equals, that's our final answer. On our next one now, you'll notice it again looks very familiar. We have two sets of parentheses. However, a really critical difference is that you notice that this time we're subtracting the parentheses, not adding them. And that does make a big difference in what we do and how quickly we make that first step. Because if we aren't careful, we're going to make a mistake here. So in the first set of parentheses, notice there's no negative or other number out front of that set of parentheses. So that one's just going to stay the same. So that's just going to be 4x plus 1. However, for the next set of parentheses, I'm basically multiplying -1 into the parentheses, which means then that the signs are going to flip. So instead of a positive 7x, we're going to have a negative 7x. Therefore, I write it as subtraction. And then we're going to be doing this -1 times -18. And a negative times a negative is a positive. And so then that becomes plus 18. So notice that minus out front of the parentheses had the effect of switching the signs of everything on the inside. All right, now that we've done that, we've done the hard part. We've done the tricky part where sometimes people will get tripped up. Now let's go ahead and combine our like terms on the left side. So I have a 4x and a negative 7x. Those are like terms because they both have the x's in them. And so I'm going to do 4 minus 7, which is negative 3. So that's negative 3x. Then I do the same with the terms that have no x's in them. So I have the 1 and I have the 18. 1 plus 18 is 19. And now we get rid of the addition subtraction from the left-hand side where the x is. So I'm going to subtract 19 from both sides. And then I'm going to divide both sides by negative 3. Because right now on the left-hand side there you have negative 3x, which means negative 3 times x. And since I'm undoing that multiplication, I divide both sides by the negative 3. And so then I'm going to be left with x equals a positive divided by a negative is a negative, and 15 divided by 3 is 5. So x equals negative 5. And again, since we have the x now by itself on that side, we've solved it. We know then that x equals negative 5. And for our final example in this particular video, we're going to be doing this problem. And again, we have two sets of parentheses, but the difference is, you notice we actually do have some numbers out front of the parentheses this time. So we're going to need to make sure we distribute those in properly first. So let's go ahead and do that. The 27, there's nothing else on that side right now, so it stays 27 until we do all the other simplifying we can do. Now on that right side now, I have a 6 out front of the first parentheses. So that 6 is going to multiply into both the x and the 8. It multiplies into the parentheses, but only the parentheses that it is attached to. So that's going to give me 6x plus 48. Having done that, I now am going to distribute into the other parentheses. But what am I actually going to be multiplying into the x and the 4? Notice here, it's minus 9 times that. So you really want to be multiplying in negative 9. So if I do negative 9 times x, that gives me a negative 9x, and therefore I'm going to write that as subtract 9x. And then I'm doing negative 9 times 4, which would give me a negative 36. So I will write that then as subtract 36. So keep track of that sign that's out in front of that number. Whatever sign this is that directly precedes the number out front of the parentheses, that sign is attached to that number. All right, so now that we've gotten this far, we can now look for any like terms. So on the left side, it's still a 27, but then on the right side, I have a 6x and I have a negative 9x. 6 minus 9 is a negative 3, so that will give me negative 3x. Then I have a 48 and I have a minus 36. So I'm going to be doing a positive 48 minus 36 here, which is a positive 12. All right, you know the way from here. Let's go ahead and get rid of our addition on the side with the x. That means I'm going to subtract 12 from both sides. And then I have negative 3x. Remember, that means negative 3 times x. And therefore, I am going to undo that by dividing by negative 3. And of course, what we do to one side of the equation, we have to do to the other. So I divide both sides by negative 3. 15 divided by negative 3 is negative 5, and that equals x. And so we now know what x equals, and we're done with that one.